Hi, my name is Tarun Awalam, and in this video, I'll be discussing the public lecture by John Wise and Gongji Li on the Nobel Prize in Physics, focusing on cosmology and exoplanet discovery. The lecture covered two major breakthroughs: the work of James Peebles in cosmology and the discovery of exoplanets by Michel Mayor and Didier Queloz. It explained how cosmology studies the universe on the largest scales, tracing how matter evolved from the Big Bang into the large scale cosmic web of galaxies. It also showed how the discovery of the first exoplanet, 51 Pegasi b, confirmed that planets exist beyond our solar system and opened new areas of research into planetary formation and habitability. Now let's get into the first part of the lecture. Now, one of the key ideas discussed was that the universe began with the Big Bang and has been expanding ever since. This expansion was first discovered when scientists observed that galaxies are moving away from us, and that farther away they are, the faster they move. This observation provided strong evidence that the universe is not static, but constantly evolving. A major breakthrough in this field was the discovery of the cosmic microwave background radiation. This radiation is essentially leftover heat from the Big Bang and comes from all directions in space, making it a snapshot of the universe about 380,000 years after it was formed. What I found especially interesting was how tiny fluctuations in this radiation eventually led to the formation of galaxies, stars, and the planets that we see today. Over billions of years, gravity amplified these small variations, forming what is known as a cosmic web, which is a large scale structure of the universe made up of filaments and clusters of galaxies. Before this lecture, I already knew that the universe was expanding, but I didn't fully understand how scientists could trace that expansion back to the Big Bang using observable evidence. Learning about the cosmic microwave background helped me connect those ideas much more clearly and showed how theoretical physics and observation work together. Now, the second part of the lecture focused on exoplanets, which are planets outside of our solar system. For a long time, scientists only speculated that such planets might exist, but there was no direct evidence. All that changed in 1995 with the discovery of the first confirmed exoplanet orbiting a Sun like star, 51 Pegasi b. This discovery was surprising because the exoplanet was much closer to its star than expected, which challenged existing theories about how planetary systems formed. One thing that I learned that I didn't know before was how scientists detected these planets. Since they're too small and too far away to see directly, astronomers rely on indirect methods, and one of these methods is the Doppler method, which measures the motion of a star caused by the gravitational pull of an orbiting object. This motion creates a shift in the star's light that can be measured very precisely. And another method is the transit method, where scientists observe a small dip in the star's brightness when a planet passes in front of it. This allows them to determine the size and some key characteristics of the planet. Now, what really sparked my interest and curiosity was how common planets are in the universe. The lecture mentioned that over 4,000 exoplanets have already been discovered, many of which are different from the planets in our solar system. After the lecture, I looked further into this topic and learned about habitable zones, which are regions around stars where conditions might allow liquid water to exist. Now, this is important because water is essential for life as we know it. And I also found it interesting that scientists are now studying the atmospheres of exoplanets to look for signs of life, such as oxygen or carbon dioxide, which goes beyond what was discussed in the lecture. This lecture strongly relates to my field of study in ECE. Detecting exoplanets and studying cosmic radiation requires extremely precise measurements and things like signal processing and advanced data analysis, all of which are core concepts in engineering. It shows how engineering plays a role in enabling scientific discoveries. Overall, this lecture helped me understand how scientists, both the largest structures in the universe and the planets far beyond our solar system. It showed how theoretical ideas, like those developed by James Peebles, can lead to major discoveries, and how advancements in technology continue to push our understanding of the universe and the possibility of life beyond Earth. Thank you for listening.